Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode 43. Last time we finished up our simulation, so before we get into another major topic, we're just going to hit a few side topics on the way in. First topic today is going to be reading input from files. I suspect I talked about this, but at the same time, I don't remember it for sure. So, just scrolling back through the previous videos, I may not have actually touched on this, which is unfortunate, but at the same time, we haven't needed it for what we've tried to do so far. So we'll just walk through some examples I've already written up here, and we'll talk through what they do. All right. So there's others besides this. This is 7, and I've only used 4 of the 7 of these personally. But we'll see what the differences are and take a look at them. I've got a little project here. It's just back to the original. In fact, I'm back in VS Code, but it's just a little step through program, and I'm going to uncomment this, and we're going to take a look at the different outputs. So I've got a very unuseful file, text1.txt. It's just got line 1 through 20 like this, so not a lot in the text file. So there's also no spacing at the end. Each line has a new line characters all that sit there. All right, so I've added system and system.io. So IO there stands for input output. So we're going to be needing that. Let's uncomment these 2 lines. So the first method we're going to look at is a static method on file called read all text. Read all text, that here it says it opens a text file, reads all the text, and then closes the file. So we'll have to remember to do that on some of these, but for this one it handles everything for us. So all we got to do is put it out the text, and we'll be able to read from it. So what we'll expect the content of the text, and then new line, and we'll start with opening brackets and then closing. That's just to see what the output is, and we're going to see it's going to look very much like the. We're going to see it looks very much like the text file. There we go. Contents, and it starts immediately and it ends immediately. So there we go. That's the easy way to read in values from a file. So there's other methods there, and there's other variants like that. Or look, there's one overload at least. You can add an encoding as well. So most things we do, I guess, are generally UTF-8. This one says UTF-8 byte order mark, but there's other encodings as well. Just to give you an example, encoding. There's the couple of the built-in ones. UTF-8, ASCII, or Latin 1, default. There, UTF-32, that's what I was looking. And there's UTF-8, and there should have been a 16, but maybe it's just Unicode. But you can change encoding, but most of the time I've just used UTF-8. If we look there at the message, there's all kinds of exceptions it can throw, though. These can happen very easily, so most of the time when you're reading a file, it won't look like this, but it'll instead look more like this. So you'll do some kind of try around it and do a catch. And then you'll catch whichever exceptions you want to handle it or let throw up or follow on up. So let's say I make this file Villain Explorer. Maybe. Villain Explorer. So we have Explorer here. If we right click properties, see if I can remember where I'm looking. Here, let's change permissions. Let's say deny write. So make it read only. No, let's make it, we can't open it. Now, if we try to run this, I think we'll see it fail. Let's catch IO accept. Let's not catch any of them just yet. Let's see it fail first. There we go. System unauthorized exception. Access to the path is denied. What that's telling us is that the file's not readable. So if we look here in this, there's probably unauthorized access. So there's one of the ones it throws. So where you can find those is in the Microsoft documents. You can find which ones it throws and what conditions they make. Here we go. Most of these are pretty explanatory, I think. We'll make it bigger. So we have argument null is a null, path too long. So in Windows, there's a max or path limit, so that's 1. Directory not found, so your path's invalid. IO, so IO is the big one. There's several different things that can happen there, and that's something went wrong trying to open it. Unauthorized, the operation is not supported. That's the one we just got. So we've locked it down so we couldn't read it, so we were unauthorized to read it, or the caller does not have permission, or it's a directory. So there's 3 different cases for it. And file not found. So the top one, the path's invalid, so whatever path you give it. This one, the file's not in the directory. And here, path's invalid, or the user does not have permission. Each one of these methods we're going to look at today will have something similar. So most of the time you would have them, you'll have a try and then catch the ones that are important to you. And maybe you don't catch them all, but maybe you catch the easy ones or the ones that you think would be common to me. So there we go. Yeah, so we could catch that one if we wanted to. Say catch system dot unauthorized exception E. Let's say console dot write. Let's do write console dot error dot write line. So write it to the error string. So most of these write lines we do here are actually write out. What that is, so in a terminal you have three ways, and I think there might be occasionally some terminals have more, but on this one we have 3 we can do. We have in, which is reading input, the console.readline. You can also do console.in.readline. There's also error, and there's out. So write line by default does out. So let's do this. So we'll say error user does not have write permission. We should probably check that that's actually the problem, but we're gonna say it is here. Let's do this. Let's do string text. There we go. Yeah. Yeah, so we're not actually using that, so it doesn't actually matter. And we can just shorten it. So here, and we'll just say return. And let's do it like this. Let's do system dot environment dot exit. will give an error. There we go. Let's see what happens now. So now we run it. We won't get the exception. User does not have write permission. So how do we know that's on the error stream? And we do notice that it gave me a error message here. So in my terminal here, it's blue, it was successful. Red, it failed, and that's controlled by the exit code. If I'd given it an exit code 0 here, it should be blue. There we go. Because I didn't know it was red. So how can we tell that it's yeah, let's see if I remember how to do this. So I think we should be able to let me go or do a quick search and so let's see. I will search for PowerShell, how to separate and error string. So what this is called is redirections. Let's see. It's the easy one actually. So easy, but doesn't necessarily look easy. Let's try this. There's just one message. Let's do another one. Let's do console.write line. So this should be going to output message. Now they're both there. Instead, let's see. Just do it like this, I think. Yeah, okay. What I'm trying to do is separate it, but so when you do it, stream 1 is output, stream 2 is error. So let's see. What else could we? I'm not. I think we'll just stop there. But if you ever run into that syntax, that's all it's saying. It's saying 2 gets redirected to 1, which is output. Here I'm saying 1 gets redirected to null, so that if you notice there's no output message. That's just a little side adventure on terminal. And I've occasionally actually used this, but it's never been the right like this. It's occasionally been like .NET run to write it to error.txt. I've occasionally done something. Now if you look, it should have there. Zeroed out that one. There's my null file. So what I did there was redirected the output string. So you can do that, and you can redirect your PowerShell streams like that, and something very similar will work in other outputs. We'll go ahead and delete those files because we don't need them. There's a little extra, but there's read all text, and it's really easy when you can just capture whatever messages you want to capture, whatever errors. But when you do it, it gives you the entire text in one string. Go ahead and comment this out. Control K, Control C. Now let's look at the second one. This one is in the same. Oops, Control U, Control U, Control K, Control U. So this one's read all lines. So read lines, read all text, read all lines. I'm doing path. I don't even think I need that. Oh, I had it in another location. I do remember why I did that. This should give us similar. It gives us we didn't add ourselves back to the access. So add ourselves back real quick. It wasn't here, it was. Now we should have access again. There we go. So this one returns an array. It opens a text file and reads all the lines of the file and then closes, and it returns a string array of the lines. So each line in the array is a line in the text file. You can see I printed out for each text line, I printed out the line here. So that one's pretty self-explanatory as well, and these are the two most common ones I tend to pick. So they have a disadvantage though. When you run these, you have to run, or when you run these, it has to fit out all the text file. It reads it all into memory and puts it somewhere. So this one, it puts it into a string. Here it puts it into an array of strings. So sometimes you don't want that behavior, and that's where we'll see next. By the way, this one throws a lot of different exceptions just like the other one, so if I was actually using this, I'd put a lot of tries around, or a try catch around it. There's just a second one, so that one's a really easy one. So let's look at the third one. Okay, Control U. Alright, so this one, if you notice, this one's structured a little differently. The other two, I've grabbed the output and then put it into a variable. This one, I'm not doing that. This one returns an IEnumerable of string. So it returns all the lines of the file or the lines that are in the result of a query. So we're just going to say all the ones in the file for the one I'm using, but do know that there's an overload you can. Alright, so what this one will do is it'll read the text file one line at a time. So as we loop through each one of these lines, it only reads that one line. It's hard to really see that. So what's really happening is it reads it one line at a time. Then when you finish with the one, it reads the next one and reads the next one. And in doing that, it only puts that one line into memory at a time, unless you save it off somewhere else. In this case, I'm just outputting it. So it's more memory efficient. And if it's a really large file, you might need that. So it can be really memory efficient, but I've used this one one time, so I've used the other two a lot more, but I have used this one for one thing, and it was a large file. It was in the range of about 4 gigs, so I didn't want to read it all at once, so I just read through until I found what I was looking for and read it, and then stopped. So I was doing a seek rather than I was seeking through it. And we'll see in a minute. There's a better one I could have used for that, but I used this. So that's reading, and you read it one line at a time and into memory, so it's a little nicer. Now let's look at this. So stream reader, and we're going to see something new I don't think I've talked about yet. That's this using statement. So let's not do the using statement first. Actually, let me comment that back out. Control K, Control C. Let's do stream reader. Stream, I just called it reader, equals new, first file. We won't worry about that. There we go. Let's see if we have an option. We do. Reader.close. So what this is doing is when we read in the file, there's something we have to do at the end. So we read in the file. We'll do string text2 equals reader.read to end, console.writeLine text2. The problem here though is that when it opens the file, it keeps it open until you tell it to close. So that's what this using statement's actually doing. So we need to say reader.close. However, there's one more thing we have to do. We have to say reader.dispose. If we actually go look in it, the dispose will actually call the close, so I don't think we need to do that, but let's just see if this runs first. I think it will. So if this one runs, it does the exact same thing. It reads the entire file into the string. So this is the equivalent to this one, sort of. but it gives us a little more control. And I say it gives us a little more control, but thinking about it, I don't guess it really does. Yeah, I don't guess it actually does give me more control because I can pass the encoding in there. So what it does give me though is as you see, there's a lot more overload. So here we can say there's a path, stream, a path. We can detect byte order marks. So you see this BOM, that's what this stands for. So sometimes you need to worry about that. You can change encodings like I said before with the other one. And you can give it some different options. Let's see what the options are. I actually don't know. File stream options dot new file stream options. There. So it gives us a little bit of more information. We can say what access level we have. We have I don't even know what options would be. We can say what a starting size is, so it doesn't have to create it as it goes. So there's just some options. So I haven't actually used them, so you'd want to read through the document and see when you would actually want to use them. So you read through the documentation. Let's see what else there is. So options. Here's a combination, encoding and byte mark. Same one but with string. Here you give it a buffer size, so you say how much you want to read in at a time. Yeah, there's a bunch of overloads, and you can use them for different things. Or you can play around with that and see what they do, and see where you could use them. So just if you need something specialized, this is what you can do it. But I wouldn't do it like I'm trying to do it here. Instead, I would do it like this. So right here, I need to call dispose. Like I said, I think dispose will do. I think it actually does the close. Let's see. Yeah, it doesn't tell you what it does. I think it should call close itself, but we don't have to think about that because Microsoft gave us some shorthand to do it. And you'll see this is not the only shorthand. So this is called a using statement. So it just says using this, so anything in this block has access to this reader. I've given it UTF-8, but we can close that. So it gets access to this reader here, and we can read it, but if I try to access it outside, it's not available. Close. You can see it's already telling me it doesn't exist. Does not exist in this context. So it's stuck within this scope, and that's a good thing because we need to make sure we do that close. And if you try to use something after it's closed, you have problems. Let's undo a minute. Let's go back and show that. Reader dot peek. Let's just peek the next one. So this should fail. It should say object disposed. It cannot read from a closed text reader. So using prevent that, so the compiler can. So the compiler at that point can say, okay, I know that you can't use this outside, so it doesn't even let me. It cannot be found. That can be nice. So what it does is it calls dispose for us, so we don't have to. And you see here it's giving me a tip, and this is a newer feature, using statement. This is I said statement earlier. This is a using expression. UTF-8 came back. So this is a using expression. Here's a using statement. They have slightly different. So right now this only applies to this, so anything here works. On the other hand, if I switch it to using statement, now it's good till the end of the current scope, and in this case there's no scope, so it's good till the end of the file, so I could use it way down here if I had more code. reader's still alive at this point until it finishes. And in normal cases, I actually like this format better. In this specific case, because the file here, because the file, it is one file, I'd actually probably stick to this one just because it's a little clearer that it ends. But the other one is valid as well. Say 4 because I know there's a couple more coming. Text 4. Yeah, that'll do. So here now I can do that. So now these do the exact same thing. In fact, all 3 versions here do the exact same thing. Someone commented out. Like I said, I may not need this line. So those 3 do the same thing though. So there's just another one we can look at and we can see using. Occasionally you'll want to do something with these disposes. We'll actually look at those, making those in future. It involves implementing a iDisposable interface, but that's something else you can do, and you can make it do something when you're done with it. And it's a C# pattern for doing that. So say you're done with a class, but you want it to always do something, like you need to clean up something. In this case, close the reader, or we can do it through this. Control K, Control C. Then comment this one. So same thing here. This could be the other style of using. Perfectly fine. So up here, we use, this looks exactly the same. This one's reading line by line, rather than this one was reading the entire file. So here we're getting each line out. So this is just reading the file as it goes. See if I had a good example of it. But it's basically the equivalent to 2 here. So, or 3. Just reading it as we step through. So that brings us to the phrase stream. So I've just sort of skipped over that. So a stream in this case it's basically just following through bytes, I believe. So here we're saying read the line. So in this case it read a line of characters from the current stream and return the data as a string. So it's saying this is the stream, so it's saying when it gets to the end of the line, that's one line, and then it keeps going, and it should seem very much like an enumerable. And if you look here, this is very similar to what I was doing up here, except I was using a for each. Well, here I don't know how long the line's going to be. So I say, well, it's not null. Going. If we run this, we should see this work. Yeah, there we go. Prints out all the lines. There's a neat one, and I have used this one. I don't know if it's still the case. I need to go, or I'll need to go actually try it. In this case, this one was really slow, while this one was really fast for my use case when I was. So maybe that's no longer the case. Maybe there some proof since I did that, but that was where I'd actually use this one. I don't really have anything else to say on it, but that's what you can use it for, and reading line by line, similar to if you had a really big file, you might try that if it's seeming pretty slow with the other method. Oh, you know what it was? It might have been. I might have even been using it before this. Looks like let's C# file dot read all lines. See, when was it introduced? That may have been what it was. It may have been before read all lines was a thing. Maybe. Framework 2. No, I should have been, or should have both have been around because I think I was in 2 and 3. I'm not sure. Maybe I was using maybe I wasn't using one up. Maybe I should have been using the other one, but I think this one was faster than the other. But I can't think of a reason it should be. As far as I think this one should be just as fast. Actually, I'll have to actually try that. So just think that this one's equivalent to this. Maybe see and actually test it and see which one. The testing in that case would be called profiling. So actually profile the code and see which one's actually faster. I feel like that's what it was, but it's been years at this. So yeah, that may be a good thing to test out for one sometime as well. Do a little light performance testing as well ourselves. Keep that as a note because that would be interesting, at least to me, just to play around with the different readers and see which one's faster. So here's us a sixth one. So this one reads characters. So this one's reading line by line. This one's reading character by character. And this one looks a little trickier. So here we're reading 128 characters. I think that'll read the entire list. Let's see. Yeah, that reads the entire one. Let's say instead, let's do 5. Here, let's say 5, and then we'll say we want the next one 9. This isn't going to be correct, by the way. Let's just take a look at it. So we run this, we're going to see we don't get line 1 through that, right? Yes. So we didn't get the line like I thought, like I wanted. So what I was wanting was the first one we get the line. The reason for that is there's a /n/r/n because we're in Windows. So if we wanted 9 there, we actually need to do 5, 6, 7, 8, 9, 10, 11. 12. I can't count. 12. Let's see if this doesn't get it. Yep. So there. Here's here's the next line basically. So using that though, we can say how many characters we want to read at a time. Say we just want to do 1. Now if we run this one, we only read 1 character at a time. That looks like a lot of space at the end. It's not really. So 3 and /r/n. Oh, there is 3 spaces though. Wait a minute. Oh, we're doing a right line. We switch that to a right. Then do a right line at the end. There's where the third line's coming from. Yeah, so now it writes them out as it expect because we're not writing them on individual lines of that. So let's cut that back out. Let's make the right line. So there, so if we needed to do something each character, we could do it like this. We could do it through this. I'm not sure that makes sense actually. Line space 1 line /r. I have to think on that. Maybe let's do this. Let's get this in Debugger. I had not opened Visual Studio on this one, but let's actually step into that. Let's see what that actually is outputting. That actually doesn't seem like it's doing what I expected. Put a breakpoint here. We probably could have done this in VS Code actually. Do over here. Let's do right click, properties, set this to copy always. Now let's run it. So what happened there was the file's back up in the home directory, but when you do a build in Visual Studio, it moves the directories longer where it needs to be. All right, so each buffer read, we have read, and it's a, right, reads an E. Here's the buffer. Let's do this. Let's go to the watch, say buffer. All right, so there, so we have L I N E space /R, and it went right on the L. So I bet what's actually happening then. Okay, so I bet that it's seeing that it's a /n then and adding it for us. So it sees it's the /n and it goes ahead and treats it as a new line. Gives us a second new line because we add one in console write line. I don't know that for sure, but that would be my guess of what's actually happening. Close that. So that's interesting. I'll add the to do. So in this case, I'll think on that and see if I can come up with a better reasoning for that, because that's not what I expected that to do actually. So I actually haven't, so another one of this one, I actually have never needed to do this one. But I could see where you could use that. So where I would think is if you have maybe like a lot of different, if you have a lot of data and maybe some characters say do this to upcoming data or do this to other data, you could do that, and you could have some kind of custom parsing there maybe. This read here, it says read however long the buffer is, it's buffer length. Read the count here, put it in the buffer is what it's really doing. So you could do that and say read this much, and then here you get a number there, like in this case 1. So we read 1, and it says how many bytes or how many next characters to grab, and you could grab the next amount, and you could do something like that. I'm just hypothesizing. I actually haven't done this. I could see something like that as a process data, and I'll try to look at that and see if I can figure out what that's doing actually. Let's do add another to do while we're here. Do consider a profiling adventure. We'll think about that one, because I like that kind of stuff, so we can go that route maybe. But this one's the most complicated of the ones. So this one is using two using statements, or using. So it's using a file stream and a stream reader. So we've seen the stream reader, we haven't seen the file stream. So this is all it does is what it sounds like. It's turning a file into a stream, and we're passing that stream into the stream reader. So file mode open. I think the others are open, create. So open, if the file doesn't exist, it won't work. So let's say we do this and we say plus wrong. That file doesn't exist. I think we agree there. There we go. Could not find file. We say open or create. This one should work. And there's no content because it's nothing there. That would work. Let me see. Wasn't there another one? There's a create, but create, if you try to create a file that already exists, fails. either failed or just what. Okay, so it overwrites. So Control Z there to undo. Overwrite. Does it say that? It will be overwritten. Okay, interesting. Thought there's another hint. Truncate. Specifies that it should open a file. So it wipes out all the content, I guess. There's a pin. That's the one I've used, so add on to the end of a file. I've used that for logging, like adding stuff to the file as it goes. Create new. It already exists, throw exception. So this one overwrites, this one throws. This is the one I've used before. That's all the options. So I like open then for files that exist. So what you would want to do there is you'd want to say something like if file.exists, I'll say doesn't exist. First file. We can just throw new exception file not found. And there we would stop that from happening. So there's something you could do. You could do all kinds of logic there, but there's something you could do. Yeah, so there's the file stream. So we're reading the file so that we can do things to it. There's a bunch of overloads there. I wonder what they don't know that I checked. Take a quick moment. New. So say file handle. That one's complicated. That one's complicated. I'm not going to mention it yet. You can read up on it if you want it. So there's path and file mode. That's the one I'm using. Path and options. So this has say different things. Sharing mode, buffer size. You can pre-allocate size. So that one I could see possibly having use somewhere. Like the file handles are something low level in Windows, so work on. I don't think that would work on Linux. So heads up on that. Both of them access. So that's just telling you what access level you grant to the file. There. Here we go. Full version. This one has a use async. We'll look at async code. Eventually it means asynchronous. So all the code we've written so far is synchronous. It all runs as we write, as in the order we write. Asynchronous doesn't guarantee that. It can do other things, and you can do that for performance occasionally. The last one has a lot of options here, and you can control a lot more to it. Let's see. Let's look at do stream mode. Was it open? File access. So access, you have three values: read, write, and write. So if we want to read and write, we would do that. We're just reading this, so I don't just want that. Let's see. File mode, file access, and file share. What file share does. Okay, so this says don't. So when I open it, I get exclusive control. So I say none or inheritable. What does that one do? I wonder. It can be handled by not supported by Win32. So that one doesn't work in Windows. It would make it shareable while child processes, but not available. Then no one can open it. Inheritable doesn't work. Write, so you can write, or so other ones can open it, write it, but they can't actually read it. You can delete it while we're writing to it, which seems like a bad idea. Interesting. So I've never actually used them. I've always just left it as none, I believe. Something like that. Option is buffer size. The default is 496, so you might adjust that. I don't know why you'd want to. I'll get that right. Path, mode, access, share, and size. Yeah, that's one. 4096, right? Okay, I don't know what it's failing there actually. Not convert from. There you go. Not convert from file stream to native integer. Interesting. I don't know. Okay. Thing. Okay, I'll have you'll have to read up on that then, because this is. Oh, wait a minute. There. Being dumb, I was passing in the wrong value there. So there we go. There's just a more advanced one, but again, what you want to do with it. So access is what level you access it. Opens what you do if it exists, doesn't exist, whatever. Shares what you allow other. I've never tried that one, so it could be something to try some. But either way, there's just some more options. This one lets you seek through the file. So right now we've got it set as 2. Here, let's go to let's see what that does first. Let's run it and let's see if it fails. So there it says start from the beginning and skip 2 places. So skipped L and I. If we want to do that, again, we'll have to keep the /r/n. So 4, 5, 6, 7, 8. If we want to skip the whole one, we would say 9. If this works. No, it didn't. It's 8. That should first line. We could do that to skip some number of lines. So where you would use that is if maybe if your file has some kind of header. Say we have clock 10:25. So there, and now we want to skip the first little bit of the file, so we'd have to know how big that's going to be. So let's see, let's do a quick maths. $64 selected, add 6 to that. 70, 72 probably. Let's see what 72 does. Let's start at 70 and let's see what that gives us a new. Let's start at 68. That gives us a new line. That gets it. So let's see. 72 wrong then. Skips to L and I again. Oh, 4. But yeah, doing that, we're able to say here 0. So don't skip anything. Start at the beginning. And then we can just start skipping however much we want to skip of a file. And you can use it to skip headers as well, where I've seen that used. I've never used it myself. I've seen someone else that does use this though. There, and then if we go up to 65, there's still extra, so we'll say 67, and I think this will be just one line at the beginning. Yeah. And 68 apparently is all of them, so I miscounted. So 68 characters. 6. That counts. It got 68 though, so yeah. So it did count right. Okay, interesting. But yeah, so there's just one more method, and I haven't personally used this one before, but I have actually seen this one once in a while, and that's exactly what it was being used for. It was parsing files, and each file had a copyright header, and it was skipping the copyright header is what it was doing. But yeah, so there's just a very quick intro to reading from files. So I'll try to see what this one was here, and maybe next time we'll look at that case a little more. Do I get the extra line there? I have a feeling I have an idea, but I'm not sure. We might try out these 2 to-dos next time and see where that takes us. So again, the idea with profiling is we're just checking the performance of our code, and in this case, I wouldn't be too sure. I would just do some testing just to see basic usage. If you're really profiling, you should use some kind of profiling tool. On Visual Studio has one built in. If you have some additions, you can try something like benchmark.net. They can help you profile your code better than what we're going to do. If we do any, it's not going to be anything major. We're just going to try to write some big files and read some and see what happens. But we'll call it there. We'll go ahead and stop with this one then. This has been episode 43 of Programming with Shadow. We've talked about reading from files. So we'll say that was a good enough lesson, and we'll stop here. So thanks for watching, and have a wonderful day.